Hey guys, my name is Zagam, and in this video we're going to talk about how to implement Mediator and CQRS design patterns in ASP.NET Core API. Well, before starting this video, I'm presuming that you guys already have the basic knowledge of what is ASP.NET Core API and how to implement it, and what is Entity Framework, a core code first approach. And if you don't, I have a separate video for that, and you might find the link of that video in the description. Because we're going to talk about a little bit advanced concepts, so it is necessary that you guys do have the basic knowledge of ASP.NET Core API. So let's just get started. So before doing a deep dive into the code and implementation of CQRS and Mediator design pattern, we're going to understand the concepts of CQRS and Mediator design patterns. These two design patterns are gaining a lot of popularity these days, especially when developers and stakeholders, they're looking for a more robust, more scalable, and highly decoupled application. These are some basic requirements of modern days web application and APIs. So these two design patterns, CQRS and Mediator, really help achieve those requirements. So let's just talk about CQRS first of all. CQRS stands for Command Query Responsibility Segregation. We're all familiar with command and query, right? And if you're not, let's just see what they are. At least we are familiar with CRUD operations. Every API and every web application, 99% of the operations in every API and web application, they are CRUD operation. If you remember an API that you had recently developed and the endpoints that you had recently exposed in that API, you would figure out that either they are fetching the data from the database, they're doing the read operation in the database, or they're doing some modifications in the database. They're either creating, updating, and deleting the data in the database. Now, what happens is when application size grows, there are different scalability requirements for the read operations, and there are different ones for the create, update, and delete operation. So according to CQRS, we actually divide our CRUD operation into two categories. The first one is query, which is the read operation, and the other one is command, which is create, update, and delete operation. So CQRS actually segregates the query from command. By segregation mean it actually separates query from command. If you remember the old architecture, we have these query and the command operation in one class or one file. Now, there's a disadvantage is that when there are different scalability requirements, you cannot apply the scalability strategies on query and command separately or independently. So this is where CQRS comes in. CQRS separates query from command, and now you can apply different scalability and security strategies on your queries and command separately. That is enough with the concept of CQRS. There's a lot more into it. When we're going to be implementing that in the code, we're going to see exactly how it works. Next pattern I want to talk about is the Mediator design pattern. Mediator design pattern is gaining a lot of popularity these days, especially when it comes to building highly decoupled modules. Now, in order to understand the concepts of Mediator design pattern, we need to understand the clean architecture first of all. We're all familiar with clean architecture, right? Which is sometimes referred to as layered architecture. It has worked for many years, and sometimes it is also called the father of all architecture. So according to the layered architecture, we divide our whole code into three major layers. So the very first layer is user interface layer, which is normally our front end. And the next thing the next layer we have underneath the user interface layer is the business logic layer, where all our business logic lies, like our calculations and doing the modifications on the data. And underneath that, we have the data access layer, where we have the strategy of communicating with our database. And underneath that, we have our actual database. Now, all the communication strategies with the database, they are there in the data access layer. And on top of that, we have the business logic layer that communicates with the data access layer in order to fetch any data. And on top of that, we have the user interface layer. Now, our end users, they only communicate with the user interface layer or the front end. It could be either a mobile app, or it could be a web application, or it could also be a Windows application or a desktop application, or maybe an API endpoints. Now, when user communicate with the user interface layer talks to the business logic layer. The business logic layer talks to the data access layer, and data access layer talks to the database. Now, this is a great architecture for small-scale application, and it has worked for many years. But there's a disadvantage. There are several disadvantages to this approach. First of all, this is all enclosed in one shell. It works as a silo. It has been closed in a capsule, so there's a very less reusability of the modules in it. For example, consider this application as a rent-a-car business. So these are the people who want to rent a car, and this is the front end of a rent-a-car website where rentees can rent a car, they can search for the cars. And then over here, this talks to the business logic layer, where we have the payment module, we have order module, we have checkout module, we have login module, and this might be the SQL Server database, and this is the layer where all our data communication strategy lies. But there are several problems to this. First one is the less reusability to this architecture, but there's a bigger problem with that. We're going to see that in a moment. The other problem, which is a bigger problem that we face, is the dependency between modules. Now let's consider that this is a layer architecture, and this is the payment module, this is orders module, this is customers module, this is logging module, and then this is email module, just for the sake of example. Now what happens is when application size is small, the communication between modules is pretty straightforward and it's very easy to maintain. But with the passage of time, when application size grows and when there are new requirements from the stakeholders, the dependency between module becomes really messy. For example, B all of a sudden starts depending on E. For example, in payment module, we might need the requirement of emailing, and then A module starts depending on C, and then D module starts depending on B, and then A module starts depending on B, and then this new dependency arose. So what happens is this communication or this dependencies between module becomes really messy, and it's almost impossible to manage. Now, that is not a very small problem. What happens is when application size grows, according to this architecture, the code base also grows, and then it's very difficult to manage, especially in the DevOps. Nowadays, in the DevOps, what we do is we do the automatic deployment. So certain architecture where there's so many dependencies between the modules, it is quite impossible to auto-deploy those on the DevOps. Another great problem that arose with this architecture is the reusability. Now, let's just consider that this B module, we want it to be reusable. Now, it has to have the knowledge of every module that it is depending on. It cannot be used separately from the E module. For example, this is the payment module and this is email module. It can only be worked with this payment module. So this is a very tightly coupled architecture when application size grows, and it's a big mess. And we want to remove the dependencies or remove the coupling between modules. So what do we do? This is where the mediator pattern comes in. So according to the mediator design pattern, there's no direct communication or direct dependencies between the modules. For example, in this particular scenario, modules don't have any knowledge of any other module at all. In fact, there is a mediator. There is a central point that handles the communication or dependencies between module. Now, what happens is if module A is looking for a functionality, it doesn't have any knowledge at all which other module would offer that functionality. What it does is it actually talks to the mediator. Now, mediator has the knowledge of which module offers that functionality. So, for example, if that functionality that module A is looking for is offered by C, so what happens is mediator talks to the module C and data is given back to A. But A should not have any knowledge of module C at all. Again, if module B is looking for some functionality that only C is offering, B has no knowledge of module C at all. So B talks to the mediator, and mediator then talks to the module C, and that functionality is provided to B. Similarly, when B is looking for a functionality that module A is offering, so it talks to the mediator, and then mediator talks to the module A, and that functionality is given back to the module B. So this is the basic concept of mediator pattern. And there's more to it. When we will implement the mediator pattern in the code, you're going to see exactly how it works. But there's a very important concept. In order to implement mediator and CQRS design pattern in your code, there are certain points that you need to keep in your mind. And we're going to see that in a moment. Before implementing the CQRS and mediator design pattern, you need to consider the candidacy of CQRS and design pattern for your project. Not every single project is a perfect candidate of CQRS and mediator design pattern. For example, if you have a small scale application, an application that is not expected to grow, for example, an HR application that is going to run within the organization and it's not going to scale at all in the future. So for that, the answer is no. You should not implement CQRS and mediator design pattern for a small scale application. And the reason is that CQRS and mediator design pattern adds more complexity to the code. So if there's a very small application, for example, a hello world application, so why would you want to write 500 lines of code in order to support 50 lines of code? So the answer is no. But if you have a large scale application, maybe an e-commerce website, or maybe an online shopping website, or a website where people actually sign up and get some services, and you're expecting that the application size will grow, and there are going to be scalability issues, and there are going to be dependency between module issues. So the answer is yes. Yes, you should definitely implement CQRS and mediator design pattern, and they're going to help you guys a great deal. Let's talk about implementing the CQRS and mediator design pattern in a .NET Core API. Now, if you remember in the last video, we created a basic .NET Core API with some crude operation. It was related to employees. So This is the API that we developed in the last video. If you didn't watch this video, please watch it now. You might find the link of that video in the descriptions. So in that API, we have basic root operation. For example, you could list all the employees from the database like this, or you could add a new employee, or you could update an employee, or you could delete an employee. So these are all the basic root operations that we created in the last video. And let's just see the code. The code is developed in ASP.NET Core API using Entity Framework code first approach, and we used migration to insert the data in the database. So in that, this is the solution. And in that solution, we have two projects. The first one is Core API, where we have our controller and also our configuration file and our startup file, the .NET Core. And then we have a class library called Data Access, where we have our context class and we have our model employee class. Let me actually walk you through to our context class. This is our context class, and it have a DB set of employees. It means that in our database, we have one table called employees. And this is our model. In our model, we only have ID, first name, and last name. In order to make it as less complex as possible, we only had 3 fields only in our model. And then this is our app setting file. And in our app setting file, we have a connection string. And this is the connection string of our SQL server, which is my local machine. And this is our startup file where we injected the dependencies for our database. So it is taking the default connection from the connection, and it is initializing the DB context service to be used throughout our application. And then this is our employee controller. It is actually reflecting to all of our API endpoints that I showed to you previously. So for example, this controller action is our get endpoint that returns a list of all employees. And this is our ID endpoint that returns a single employee based on an ID. This is our post endpoint that creates a new employee. This is our put employee that updates an existing employee based on the ID. And this is our delete endpoint that deletes an employee from our database based on an ID. Now, if you see that in that employee controller, we are directly using the employee's DB context from our data access, which is definitely not a good approach, because this is highly coupled solution where our controller has a full knowledge of our employee context, which is not a good thing. A controller should not have any idea of our employee context. So it is directly communicating with the employee context. And now we are going to implement the Mediator and CQRS design pattern to see how we can eliminate this dependency from the controller and shift it all to our CQRS and Mediators. So the very first thing we need to do is that we need to add a new NuGet package in our solution, which is the Mediator NuGet package. So all you need to do is you need to click on Manage NuGet Packages and go to Browse, and then look for Mediator. And just to make sure the Mediator doesn't have an O before R, so it's Mediator. It's the Microsoft term. Let's just look for it. And this is the package that we want to install, and also this one, because we also need to add this dependency in our startup class. So first of all, you need to add this Mediator pattern, which is added, and then we need to add this Mediator dependency injection extensions in our projects. Great. The next thing we want to do is we want to add the dependency of this Mediator in our startup class. As you know, that this configure services method is the method in our startup class where we define all the dependencies for our application that are going to be used throughout our application. So this is how we do it. We call it services.add Mediator. So we don't have it because we didn't include it here. So you need to use using Mediator. See, we have it now. Now we can have add Mediator. Now, this is where we want to add the assembly of the project where we have our data context. Now, our data context is in our data access project, and we want to access the assembly, and we want to add the assembly of this project into this Mediator. So what we can do is we can do type of. Now, if you say using data X, you can see employee data context dot assembly, because we are looking for assembly, not the actual class. Now, this could be any class. It could be either employee DB context, or it could be employees model. You can also have the employees model. If you can add this model here using data access dot model. So it could also be employee model, but that's not a good approach to randomly pick any of the class from from this class library. So what we can do is we can add uh, a new class called entry point. It'll be an empty class, entry point, and it has to be public, obviously. But the point is, I think I need to rename it to entry point. Entry point, yeah. So this class has to be empty, and there's no use of this class. But the point is, it has to be a class that returns the assembly of this data access. And you need to do is you need to use data access layer. Yep. Now, the mediator dependency has been injected in our project. And next thing we want to do is that we want to implement the CQRS design pattern. In order to do that, we want to segregate our queries from our command. So this is how we implement it. In our data access layer where we have our context class, we need to add 3 new folders. The very first folder would be queries, where we will have all our queries related to employee. And we're going to have another folder for commands. This is where we're going to have all of our commands, like insert, delete, and update. And another folder would be the handler. Handlers are going to be the handlers of command and queries. This is where our actual query will reside. Now, first of all, we want to write our queries. So if you remember, our endpoint, our very first endpoint was to return a list of all employees from our database. So in order to do that, just go to queries, right-click, and add new class. And we call it get all employees query. First of all, we need to declare it as public, and we want to declare it as a request because this is going to be requested by our controller. Our controller is not going to be accessing our data access layer or our context class directly. Instead, it's going to be sending a request for get all employees, and it has no idea whoever has implemented it. So in order to do that, in order to declare it as request, we want to implement it as request. A request, and this is where we return, where we declare the return type of this request. So we are expecting a list of employee from, I think it's employee. And we want to add assembly for this, which is model. And I think I missed a semicolon here. Now, this is the syntax of a query, a mediator. But there's a short form in .NET 5, which is a record. When you do that, you don't need these braces and parentheses. All you need to do is public record, get employees query, and I request of list of. This is a short form of the same thing that we did earlier. Now we have defined the queries. Next thing we want to do is we want to define a handler for this query. The handler is going to be placed where actual query resides, where we actually communicate with our context class for getting the list of employees. So in order to add a handler, just right-click on the handlers folder and add a new handler, which is a class, and we call it get employees list handler. You can call it anything you want, but first of all, let's declare it as public, so that it is accessible outside the namespace. And then you, first of all, we need to add the mediator, and then we also need to add queries because we're going to be accessing the query that we just created. Now, in order to declare it as a request handler, all we need to do is we need to implement the iRequestHandler interface. And now this interface takes 2 arguments. The first argument is the query that it's going to handle, which is get employees query, and the other argument is the return type. The first one is the request, and the other one is response. And response has to be the return type. So the return type or get all employees query is the list of employee, and we need to return the list of employees. So in order to do that, first of all, you need to include the namespace, which is data access.model. And then over here, it will return the list of employee. Right. So this is how we declare our class as a handler for the get all employees query, and this is the return type. Now we need to implement that interface. In order to do that, we need to click on implement interface. Now when we implement it, it has a handle method that we override. it receives a request. A request is of type the get all employees, and then we have a cancellation token. Since this all runs in an async task model, in asynchronous way, so we do have a cancellation token, because when any operation runs in asynchronous way, we have to have a cancellation token to cancel that task. Now we need to implement this, and this is where we need to actually talk to the employee context class to fetch a list of all employees for this query. So in order to do that, the very first thing we need to do is we need to inject the context class, which is injectable by default. So we find the constructor, and in the constructor we need to have the context class, and we know that context class is in our data table. Now employees dd context, and we call it underscore context. And now we need to initialize this field with a private property, and this is how we do it. And now this context class is the one that we can use in order to fetch it. Now we need to use this context class, context.employees.toList. And what we do is we actually return it. But since this is a task, so what we do is return the task from it, which is task.fromResult. And again, since this is async task model, so we put the word async, and over here we return the word await. Now our handler is complete. The next thing we want to do is we want to use this query to get a list of all employees in our controller action. So in order to use this query in our controller, just open up your controller, and this is the endpoint that we want to take, because this is the endpoint that is returning a list of all employees from our context object. So first of all, you need to add the Mediator namespace in your controller, which is Mediator. And another thing that you want to add in advance is data access.queries, because we know that this is the query that we want to run. Now just remove this context.employees. Now over here we use the Mediator, and another thing is that we need to inject the dependency of Mediator in this controller, which is the .NET Core way of injecting the dependencies. So all we need is iMediator object, and we call it underscore Mediator, and we want to initialize a private property from that, which is going to be Mediator. And now we can use this private property throughout our controller actions. Now we need to do is, all we need to do is that we need to write mediator.send. What it will do is it will send the command to the Mediator, and Mediator will then decide who has this command implemented, where is the handler of this command. So our command is new get all employees query. That's it. This is all what we need to do. But why is it yelling? Because it is returning a task. It is not returning a list of all employees. So we need to implement the async task model. And in order to do that, what we need to do is we need to change the return type of this controller action to be task of list of employee. Now over here, what we do is, we call it async task, and over here we say await. Now this is done, but there's a very short form of it. Nowadays in .NET 5, it also supports the Lambda function. So what we can do is we can use the error function to achieve this. In this case, you don't need a return type at all. This is equivalent to what we had before. So I think this is pretty much it. Now we need to run this, and we need to see if it works or not. Just run the API. Now this is our first endpoint that we just changed. Just click on try it out and then click on execute. See, cool, we have a list of all employees. So it works. In the next part of the video, we are going to change all the post endpoint, the commands, and delete endpoints according to the Mediator and CQRS design pattern. But before doing that, we need to understand the underlying magic as well, like how we have decoupled our application and how we have decoupled our application components from one another, like how we have decoupled our controller action from our context class. And this is how we achieved it. Now, this controller action, previously it was directly accessing our data context class, but now it is not accessing any data strategy. It is just sending a command to the Mediator that I am looking for a list of all employees, which is this query. Now, Mediator, when it goes in this query, it looks for the handler, whoever implements or whoever handles this query. So it finds the handler right here. It finds that this is the request handler that handles this request, and this is what it returns. Then it goes into the handle method, and this is where we have implemented, or we have actually talked to our database in order to return a list of all employees. This then returns the list of employees back to the controller, and this is how we return it to the end user. Now, the next thing we want to do is that we want to implement a command uh, in the Mediator. The very first thing we did is that we implemented a query in the Mediator, but in the CQRS other part, we want to implement a command. So over here, we have this command. This is the endpoint that inserts a new employee in our database. So in order to implement a command, all you need to do is you need to right-click on your command folder and add a new class. And we call it insert employees command. Now again, first of all, you need to declare this class as public and include the required assemblies, which is Mediator, and also using data access.model, because I knew that I'm going to need it later on, so why not just add it first of all. And as you remember, it has to be a type of Mediator request. And Mediator request of type employee, because this is what we're going to return. What I want to do is that I want to return the newly employed that is being added in the system. I want to return it. And that's it for now. But if you remember, instead of declaring it as a class, you can also declare it as a record, which is exactly the same thing as this one, but it's a short form. Next thing we want is we want to add a handler for this command. We do have a handler folder, so just right click and add a new handler. And we call it insert command handler, employee handler. And again, just include the required assemblies and also the model, which is data access.model. And also we need to add data access.command, because we don't need the query this time, we need the command this time. Now declare this class as public and implement the iRequest handler. This time we want the insert command, and the return type would be employee. Oh, and now we need to implement this interface. We implemented it, and now we just as previous, we have the insert command and the cancellation token. So it's going to be on the async task model, so it has provided us a cancellation token in order to cancel the task. Now, just as before, this is where we are going to implement our strategy of talking to the database. Now we know we need to add the context object here. So in order to do that, we need to add a constructor. And within the constructor, we need to add the data access or the data context object. But before doing that, I just remember that I left something really important, which is adding a parameter for the new employee that has been inserted. So in order to do that, we need to do the employee. Now, this is the employee that will be received from our controller action, and it is very necessary to put this as an input. It is the same as if you didn't have a record, if you had a class, so it would be like having a public property with the employee. So this is the exact same thing. Now just come back to your employees handler, and now you need to add the employees data context and just add a private field from this underscore context, which will be this one. And now you can use this context object in your handler. Now this is where we're going to implement our handler, and it'll be context.employees.add. And now we can get this newly added employee from the request object, which is employee. Remember, we just added it in the previous step. And now we need to do the save changes, which is actually going to talk to database to add the new employee. And now we need to return this newly added employee as the return type. So we need to return, as remember, task.from result, and it'll be request.employee. Now, one thing you need to do is you need to change it to async, and then we need to return the awaitable form of this method. So we're cool. Next thing we want is that we want to change our controller action to not to use the context object. I think it was this one, not to use the context object to add a new employee. Instead, use the mediator and our command to insert a new employee. So in order to do that, all you need to do is you need to first of all, change the return type, which is task of employee. And then here, we need to use the mediator dot send. That's it. And now we need to add the command that inserts a new employee, which is we just created insert command. And this insert command takes one argument that we just created, which is an employee, and we have value as an employee. Now, in order to make it async task model, we need to return the await form of this method, which works perfectly, but in .NET 5 we have one liner for this, which is the arrow function, and this is how we create it. So we, in that case, you don't need a return statement. So this is how it works. So let's just run this application. And this is the Swagger UI of this application where we're going to test our endpoint. We've already tested our endpoint, which we converted on Mediator and CQRS, and this is the one that we had just converted. Now, if you try it out, so it will give you this JSON. It gives you ID because we didn't have any DTO that only represents first name and last name of the employee. But we have the entity as an input. So just to remove the ID because it's not going to use this ID. It's going to create an ID of its own. So now what you can do is you can add a new employee, which will be Nathan Marshall. Just a random fake name. Now click on execute. And see, the new employee has been added, and the ID it has assigned is 6. And if you go back and try out our get all employees endpoint, you see that this Nathan has been added in our in our API, in our database. So that is cool. Today we have seen that how we have implemented the CQRS and Mediator design pattern in our .NET Core API. We also understood the concepts and requirement and the benefits of using the CQRS and Mediator design pattern. And thank you very much for watching my video. Please subscribe to my channel and keep watching my video. Thanks.